How's it going, everybody? I am a pretty happy camper right now because I finally was able to get VXLAN EVPN Multisite to work with pings. The farthest I had gotten it previous to this was the control plane to propagate MAC addresses. And I thought that was a big deal. So I went and I did a little bit of further checking, and it's like, oh, I wonder if I add this, and if I wonder if I add that, and it's working. So we'll talk about that here in just a second, about how it all comes together. But there's a lot to unpack, so I'm going to do my best to try to organize it and to show you the configs as I go. I won't be walking you through the config because there's like 10 things that have to be working correctly for this to work. So, but it does work, and there's a lot that needs to go into it. So let me go ahead and jump over to my desktop, and we're going to walk through what that actually implies, or what it entails, I should say. So the way that this works is, let me actually go ahead and create a custom shape and make this guy a little bit bigger, just so we have some room at the bottom to play with. Go ahead and pull this up. Alright, so here's what we're going to go do. I'm going to go do a little bit of whiteboarding here with you guys to try to help with the understanding process of how all this stuff comes together, because there's a lot that goes into it. So let us draw, shall we? Alright, so essentially let's start off without using border gateways, and then we'll talk about with border gateways. So if you have, let's say we have site 1 and we have site 2. Then we have super spines. I'm just going to draw one. Super spines, there could be times 2 or more over here, and the super spines are going to connect down to the spines here. So if we have spine 1, well, let me just draw it like this: spine 1 and spine 2, and we have spine 1 and we have spine 2. If these guys all connect up here like this, and then down here you have leaf 1, you have leaf 2, and you have leaf 3, and you have leaf 4, and leaf 5, and leaf 6. And then these guys are all going to be wired up like this. And all that good stuff that goes along with it. Alright, so all this is connected. And down here you have, you know, whatever connections you have, servers down to other switches, so on and so forth. In this design here, when you have it, you're going to have a bunch of NVE peers, right? So NVE peers, Network Virtualization Edge, you're going to have a bunch of peers going on. Whether you're leveraging ingress replication or multicast, it doesn't really matter which one you're going with. For every leaf that you have, you're going to have a connection to every other leaf. So in other words, you're going to have a connection from here to here, here to here, here to here, and then obviously here to here to here, so on and so forth. And then all these connections are going to be going over. And I mean, I don't have to go into much more detail than I'm already doing when it comes to how all this stuff comes together and all that. Obviously, you can tell that that is just a bunch of work, right? It takes a lot to make all that stuff happen. So in a situation like that, obviously not the most ideal situation, right? Because it just, you're compounding the amount of NVE peers that you need to have. So to fix that, there's another way of doing it. So you have over here at site 1, you have, and then you have over here you have site 2. And what you end up doing over here is you have your spine 1, and you have spine 2, and you have leaf 1, you have leaf 2, and you have leaf 3, leaf 1, or we'll do leaf 4, leaf 5, and then leaf 6. You'll have spine 3, and you have spine 4. Well, we're not going to do a super spine design because that obviously implies that all of your leafs are going to have NVE peers to each other. Instead, we're going to use the concept of a border gateway. and a border gateway 1, and then we're going to have border gateway 2. And what ends up happening here is you have all these connections here going on and so forth, just like this. Now, what will end up happening is spine 1 will have a connection to border gateway 1, spine 2 here, and then spine 3, and actually let's clean that up a little bit. And this will be connected, right? And then what you use with the border gateways is you connect them together. Now in our case here, we're not wiring them directly together. We're going through a data center interconnect. Now this could be internet. This could be MPLS. This could be a whole bunch of different things. So what we've actually got some wiring going on. I'm physically wired to here and I'm physically wired to here. So we'll say this is the 101 network and this is the 103 network. Because these numbers are going to come into play later on once we get into the config. And what we're doing is on border gateway 1 and border gateway 2, we have an additional loopback that we created. So loopback 0 is used for internal connectivity. So this will be for OSPF, PIM, and then IBGP, right? Same thing over here. Now loopback 100 is going to be for the DCI and L2 VPN eBGP configs that are going to be used to connect border gateway 1 and border gateway 2 together. And both of these guys are going to have loopback 0 and a loopback 100 deployed. What's going to happen is we're going to get the normal internal routing squared away, right? So we're going to have like server 1, I'll put SRV 1 here and do SRV 2, and then we'll do SRV 3 and then SRV 4. Right? These guys are all going to be wired up like this. This is just this is logical and hypothetical, not the way that it's actually going to be done. What we're going to do is we're going to get all of this connectivity working. So between here and here, there's going to be IBGP, right? And then between here and here, there's going to be IBGP. And that's going to be necessary for doing all of the layer 2 VPN connectivity. On the border gateways, you're going to create your VLANs and your VNI mappings. You're going to do your NVE interface, and you're going to associate BGP as the reachability protocol. You're going to specify multicast connectivity. Same thing over here. You're going to do your VLAN and your VNI mapping, as well as your NVE interface. So essentially, if you were to do a show NVE interface on either one of your border gateways, you should see NVE peers to any of the leaf switches. So there'll be an NVE peering here, an NVE peering here, and an NVE peering here, because these are all VXLAN connections here. Same thing with this guy. So he'll have connections this way down to any of these guys, and these will all be VXLAN tunnels built between the border gateways and the leaf switches. Now that gets you your connections to the border gateways, right? Now beyond that, what we have to do, and this is what I did in order to get this to work, is I created a route map. So I'll say RM, and the route map was designed to call this interface right here, the loopback 0 and loopback 100 interfaces of both devices. And what I did is underneath BGP, I configured a BGP peering, a multi-hop, so a multi-hop eBGP peering between border gateway 1 and border gateway 2. And how you do that is when you do your redistribution for with this BGP peering here, so between DCI and the border gateway 2, you do an eBGP peering here and an eBGP peering here. And underneath the IPv4 address family, you take the route map that you create up here that's calling the loopbacks and the the interface that connects the border gateway 2 and border gateway 1 to the DCI, so the public addressing 103/24, 101/24 on a per border gateway. What you do is you redistribute that into the IPv4 address family. And then that allows loopback 100 of border gateway 2 to be learned by border gateway 1. And then once you have that in play, between border gateway 1 and border gateway 2, you can form a eBGP multi-hop layer 2, that's a horrible 2, layer 2 VPN, EVPN peering. And you source it from loopback to loopback. So we're going to have border gateway 1 and then border gateway 2, and we're going to have the DCI sitting here in the middle, and then we're going to be doing a multi-hop eBGP peering between the two. And this is what allows you to extend a connection from border gateway 1 to border gateway 2. And because border gateway 1 has an NVE interface, and so does border gateway 2, because they have NVE interfaces, we're able to form a VXLAN tunnel between these guys. So this is VXLAN as well. And by doing that, what we end up getting, once we're all said and done, is we end up getting MAC address propagation. Now there's a couple of additional things that need to be done. When we're doing this eBGP multi-hop layer 2 VPN connection, we need to specify that it's a fabric external peering. We also need to specify that we're going to do some route target rewrites so that we'll match the route target values if they need to be modified. We're not going to really go into too much detail on that. Now on the border gateway, for the connection down to the spines and the connection out to the DCI, you need to put in the command is going to be eVPN Multisite, and you're going to do fabric and DCI tracking. And basically what that does, essentially, is it allows the interfaces on the LAN side as well as the interfaces on the DCI side to be tracked. And in the event that there's a problem, you're going to fail traffic over to another border gateway. We're only going to test with 2 border gateways. I do have 3 laid out, but I'm not actually going to configure it so that it's easier to work with long term, and I might even adjust the topology so we only have a single border gateway. But right now, a singular border gateway is more than sufficient to do the job. In the event that you have 2, let's say you have border gateway 1 and border gateway 2 at the same site, so site 1, for example, there is a designated forwarder election that does come into play where you'd have to determine which specific border gateway you're going to send and receive traffic from. So keep that in mind if you're going to do high availability, but for the most part, this is where it all comes into play. It's a lot to unpack, as you can obviously tell. So I'm not going to walk you through the config of how this works and actually configure it. I will just do some show commands and tie it all together. But that's at a high level, this is basically how it comes into play. So let me go ahead and clear the screen. I come up here, pull up the command line, and I've gone ahead and pulled all the configs off the boxes that are necessary. So essentially this is what's going to happen. Is make sure that nothing has failed. Because every once in a while devices will check out and they'll no longer be working. Okay, everything looks pretty stable so for right now, so we should be able to do some testing. So essentially what we've done is, so if we look on Leaf 3, it's going to be one of those things where we have to have everything configured the same way. So if we do a show run VLAN, we have to have the VLAN configuration in place. So we have to have VLAN 10 and VLAN 100. VLAN 10 is going to be our subnet that we're trying to bridge across. So essentially what we're trying to do at the end of the day is get Leaf 3 right here and Nexus 9K1 to be able to exchange information with each other through the control plane, which is why we have BGP working. And that also allows us to send pings across the network. We have VLAN 100 created to do the layer 3 VNI if we ever wanted to take it that far. We do the same thing on leaf 4. So we do a show run NV interface NVE1. You're going to see that, and I never associated the VRF. That's okay though. We're not trying to do any inter-VNI routing right now. We're just I'm using the layer 3 connection here just for the propagation of information. But essentially, I've got the member 10,010 associated for the VNI to the NVE interface. And if I go to show run BGP, what I did was underneath the address family for VRF customer 1, I added in the subnet that I'm trying to advertise. So this helped with the propagation, and underneath the VRF I added in the ability of the information to get passed back and forth. So just like we talked about in layer 3 VNI, I'm not going to rehash all of that stuff again here, but that's basically what we ended up doing in order to get this to work. And then now that that's done, when I go to Border Gateway 3 and I do a show BGP L2VPN EVPN summary, I'm getting a bunch of routes coming in from the spine, right? So I'm getting 2 in from spine 3, which is 10.0.1.23, and you can see from 172.16.100.1 I'm receiving 8. So if I hit the up arrow and pull this back and I look at VNI 10,010, you can see that I'm learning a bunch of them in. I'm learning in the MAC addresses from PC14, PC13. I'm also learning in PC33 and PC32, and then a couple of other ones from some of the other sites from the devices that are inside of the Site 1 deployment. So we have that in play. So the config on this guy is a little bit more involved. The leaf config that we've got deployed here is no different than any other leaf switch that you would ever deploy. The leafs don't really have anything going on. It's the border gateways where all the heavy lifting is done. So here if we do a show IP interface brief, we can see that we have the loopbacks deployed, right? The loopbacks are configured, and if we do a show run section BGP, not section, sorry, yeah, it'll work. What we had to do was we configured BGP, host reachability protocol BGP, all that type of stuff is in play. And then what I went through and did was global BGP. I set up a peering to my local provider. So this is the DC1. This is a peering to the DCI. And then I'm advertising the address family IPv4 unicast. And what I'm doing with this route map, if we do a show run pipe section route dash map, you can see that we're doing the loopback 100 address, Ethernet 1/2, and loopback 0. We're advertising all of those interfaces into BGP. And by doing that on both Border Gateway 1 and Border Gateway 3, we're able to mutually exchange the information that we need to have in play in order for this to all work. So this is for underlay reachability, so that Border Gateway 3 and Border Gateway 1 can learn about their loopbacks. And then from there, we are taking it a step further, and we are creating a Layer 2 VPN point-to-point eBGP multi-hop peering. This is that eBGP multi-hop Layer 2 VPN peering. So here I am, I'm pointing towards the loopback address of Border Gateway 1, the remote AS that I'm peering to. I'm peering from loopback 100 to loopback 100 is what my goal is to do. And then I'm saying this is eBGP, meaning it's by default eBGP defaults to a TTL or time to live value of 1, where here we're going to be saying 5. Technically we only need 2 because we're going from, this would be the first one and this would be the second one. So I'm saying 5 for just good measure. The peer type is fabric external, so meaning that we're going to be connecting to an external site, but we want to extend our Layer 2 VPN fabric across this DCI or data center interconnect. Then we're enabling the Layer 2 VPN address family, and then we're sending our extended community values for the appropriate route target value, route distinguisher value information to get propagated. In the event that we need to rewrite the EVPN route target because we're going from one AS to another, this is basically how that comes into play. So the information passed back and forth is symmetric, and we don't have any problems with ingesting any of the information that's being passed back and forth. Now, once that's in play, then I have to look at the show run interface, and you're going to see that on the E1/1 and E1/2. As soon as that pulls up, might take it a couple seconds. Again, this lab is running really slow, and I'm hoping nothing crashes between now and then before I do my pings. So actually, I can scoot up here to the top. One of the things we're having to do on the interfaces, let me just scoot up to the top here while I'm waiting. If you look right here, you can see that on the connection to the internally, we are doing, so anything that's LAN facing towards spine 3, we are doing fabric tracking for multisite, and then, oh, there it goes. So we're doing fabric tracking here, and then for anything connecting to the internet or to the DCI connection, we're doing DCI tracking. And this is required in order for this whole solution to work. Then if we were to do a show run pipe section EVPN, what we're going to basically end up having to do is underneath EVPN, globally we specify that this is going to be EVPN multi-site border gateway and then site identifier 2, and we're saying delay restore time is was it 9 minutes or so? So we have that in play, and then underneath the show run interface NVE1, we are associating EVPN multi-site. Underneath, we're saying that globally, we're saying, okay, loopback 100 to loopback 100 is going to be the peering, and then we're doing IPv4 unicast ingress replication updating between the border gateways and all that good stuff. So now that that's in play, that gets us back and forth communication for what we need. And that allows all the communication to pass back and forth. If I go back over here to Leaf 3 and do a show BGP L2VPN EVPN for VNI 10,010, you're going to see some MAC addresses in here. The 680D, 680E, these are coming from the remote site. So this is PC13 and PC14 respectively. And then I'm also seeing 6820 and 6821, which are PC32 and PC33. So now, with that being said, let's go to PC32. And here I was pinging from PC32 over to PC13. So if I hit the up arrow, the ping does work. So I have data plane reachability in place for this to work. Now, if I was to ping 33, that should work as well because we're inside of the same data center, right? Now, if I want to go ping 14, that should also work. I should be able to ping PC14, which I can. Now, PC12, I will not be able to ping, or I'm sorry, PC20. I won't be able to ping him because he's in a different VLAN. I will only be able to ping the things inside of VLAN 10 that are in the other site. Now we go over to PC13 and I try to ping 10.1.10.32. That should respond as well. So that means that the DCI connectivity is working. So what I can do, let me see if I can't get a Wireshark capture here going on the DCI. So let's capture on gig 0/0. Let's see if we can make this happen. Fingers crossed that I'll be able to make this work. This should be VXLAN encapsulated. Yep, let's track this real quick. See if it'll happen. So, alright, so we see BGP going back and forth, which is awesome. Let me go ahead and pull up Secure CRT again. And let's go ahead and do that ping one more time. And we can see ICMP going back and forth. So if we look at the ICMP, we can see that it is VXLAN encapsulated. And that information is going back and forth the way that it should be. So we can see that it's VXLAN encapsulated and everybody's happy. So that proves that the data plane, it does work on the Nexus 9000 Vs. I was actually very skeptical about this, but it does work the way that it is touted. Let me see if I can't go in here and do an ICMP. Yeah, it won't let me do a specific ping or a specific filter. But if I ping 33, you can see that 10.1.10.13 to 10.1.10.33, this is working all day long. And we can see that it's coming across UDP, VXLAN, and then the internal information. All that stuff is being exchanged back and forth between the devices. So EVPN multisite does work, or VXLAN multisite does work in the data plane. You just have to make sure that you have everything right. I have gone ahead and copied out all the configs from all the devices that are appropriate here. Part of me wants to do Border Gateway 2 to test this out with a multi-border gateway design. It wouldn't be hard to take Border Gateway 1 and tweak some of its configs and get that all online. I'll give it a shot to see how it plays out. Fortunately for me, if any box crashes on me, I just copy and paste the configs back in, get it back online pretty quick. So I'm going to test that out real quick and see if it actually works. And then an additional test for me would be to push the gas a little bit further, would be to add in VLAN 10 on the new leafs and then try to do inter-VNI routing in this design and that type of stuff. But right now, I'm a happy camper. So I don't know how far I'm going to push this because the lab is already pegged as it is. I don't want to crash anything, but it's working with the design. So I want to thank you guys for stopping by and hanging out with me in this video, and until next time, guys, take it easy.